So this past weekend, I was at a garden center, and I took part of the UK ritual of going to the garden center, purchase hundreds of quids worth of plants, which will subsequently die due to poor maintenance over the summer. But that's not the point of the recording. The point of the recording is I noticed that this garden center in particular had one of these queue management systems. And what that means is essentially that in the queue system where you queue up, they have a bunch of tills. And by the exit or where you enter the array of tills, there's a screen that says next available till. So when a till becomes available, it will pop up on the screen. Now, the reason why I brought this up here is because I thought that would make for a good tutorial in vibe coding one of these using the Screenly Edge app environment and building something like this from scratch, because really it's not that much stuff under the hood here. I'm sure there are a bunch of edge cases, but when you have to do integration with the POS systems and whatnot. But what I'm talking about here is basically this. So you have a call forwarding screen, and this is where we're going to use the Screenly Edge app. You have some kind of queue API, and the customer is obviously looking at the screen, and you have a POS system that triggers the next till available over the API, I presume. So this is how I'm going to redesign this. And obviously, I'm not going to build this necessarily production grade, but let's vibe code our way to something that kind of does this. So before we dive in, let's start with architecture in the backend. So again, I'm not going for production grade here. So let's do something basic. So I'm thinking we probably want to build an API that returns the latest till with some kind of TTL value or time to live value. So we make an API call and to this API, and we'll tell you the till's available for, I don't know, 10, 15 seconds. So I'm thinking we probably might use something like Fast API for Python, running a Docker container, and then maybe we use Redis for the backend storage. So you know what? Let's get cracking. So before we dive into the Edge app, and before we dive in, I've done this diagram in D2. It's available in the repo, but I'm going to kill this now, and I'm going to kill this, and let's go back in here. So before we dive in, you need to install the Screenly CLI, which is on GitHub. CLI. You can pull it down. Once you've, I'm using Brew, so you can install Brew for your Mac OS, but Nix, a bunch of other ways to support it. But I've logged in, so you need to log in using Screenly. Log in. I've already done this, so I'm just gonna not bother with that, but just so you're aware of that. And you also need a Screenly account and a screen. I'm gonna use a virtual screen or a Screenly Anywhere device, for Screenly. So that's the quickest way. So you can run this in any web browser. But during the development, we will be using the local development environment, which is part of the Screenly CLI. All right, let's get cracking. I'm going to use Cursor to do this. I've created a new folder in here called Queue Management. And, Edge apps. And then Queue Management System. I've already put my diagrams in here. So let's start with creating a, let's break it up between server and client. So let's start with server, and then we create a client as well for good measures. So let's start by prompting a Cursor to build us the plumbing for this. I probably want to start with kind of the architectural side. So inside Edge apps, server. I don't think there is any more server for a folder. You won't find it. All right. I'm just gonna open it then. So let's start this. Docker compose file that runs Python and Redis. Latest Python version. Docker container. Then make sure they can. I want this in the Edge apps queue. I'm just gonna copy this from here instead. I want it from this folder, so I'm just gonna copy this in. I want to use as the root folder. We will be using the client folder later. So the scaffolding. So let's cursor crack away here. Let's see. Let's see. I need to see the Explorer as well. Server. Move the compose file down into the server folder and not in the root. All right, that looks better. All right, so we have Redis, we have a Docker, perfect. It's listing on 8080, environment Redis. That all looks fine. Great. Let's create a file as well. We don't need to bore about multi-stage build or anything as well for now. So that's latest, perfect. Requirement file. Yeah, that's kind of fine. Oh, it's suggesting to use Fast API. Okay. I haven't even told it about that yet. Okay, that's fine. So we don't want to use .env as we will be using variables. So I don't really care. UV core presenting. So no need for testing right now. So we don't really care for the test, so we're just gonna do a quick demo. Obviously, again, if you're doing production environment stuff, you need to have a test suite. But let's just keep things simple. So let's remove Pydantic, all that stuff, and keep it simple. Let's see what the main.py file looks like. All right. Good stuff. All right, so we have plumbing. It even picked Fast API before I can even tell it to use Fast API. You know what? Let's just see what happens if I do this. So I have the architectural diagram. I'm just going to do this. I'm just going to screenshot this architectural diagram, check it into cursor. Trying to build. What we're building now is the QA API. We will have a client as well as an API client to the POS. Cool. All right, let's see what happens here. So it's parsing that diagram I just made. D2 is awesome for making diagrams, by the way. I love it. So interesting. Okay, so it's inferring quite a lot already here in the model. Okay. Interesting. All right. So it's building out our models. Interesting. So ticket number, customer name. We don't have customer name. That's not something we'll have. I guess you could have in some cases you would have that. Simplify things further. No name. We just want to show the status of the next till. Let's use Redis and TTL to track the next available till. The call forward screen will pull the API and display it on the screen, whereas the POS will make a post against the API. All right, let's see what it comes back right here. All right, so now it simplifies things a bit further. And again, we're using Redis, so in theory you could have multiple servers. We could have stored in memory really, but you know, we're here. So let's try this. Let's see what it comes up with. One thing we need to consider. All right, cool. So that we just make it get on display. I don't like the busy logic here. Let's just make it call. Actually, we do need to track the busyness level because otherwise, if there's no queue, yeah, we need a kind of a Boolean tracker there. That's a good point, actually. Okay, that's fine. That's fine. Let's implement an element this, and let's try it with curl. All right, let's see what happens. So it's pulling Redis. That's cool. And we should have a web server running now on port 8000. So Cursor is building it. It's fine. Let's do all the dependencies. Oh, interesting. So it's missing some dependencies. I wonder what's needed Rust. Let's look here. Let's let's look at the requirements file. What we have here. Oh, UV corn. That's Rust based. Okay, so it's suggesting running curl inside. Don't add curl inside. We will try it outside. Okay, so still wants Rust. Let's see if we can build. I have a feeling that the reason we need Rust is for this component. You know what? Let's not use UV icorn as use a basic server. Okay, that seems better. Let's modify the Docker file. Cool. That's fine. Oops, it's popped into the wrong folder. Okay, actually we don't need the volumes, that's fine. It's yeah, that's why they show the cursor when it tries to deal with. Okay. It's fine. Roll back to older Python version. It's fine. And the whole idea of this exercise is like, how can we do that writing a single line of code ourselves? So that's the whole challenge here. So I already got something running on port 80. So let's do this. I'm just gonna clean up my Docker files. Oops. I've already got a few containers running. Let's remove those. Now 8,000. It's fine. I had a different service running on port 8,000. Alright, it's nothing running now. So let's revert back to port 8,000. Alright, so we now have running. Let's try that. Yeah, let's try to run it. Ooh, it didn't like that. Right, so we found some issues. Aha. Found our first bug. I mean, it wants to use Flask instead. That's fine. That's the problem you have when you start doing this vibe coding. Like, it just makes radical changes all the time. But YOLO, am I right? This is not how we write production code at Screenly, by the way. All right, so at least you could hit the endpoint. And available tools 1 to 3, busy tools, blah blah. Okay, this is cool. So it's making a post here. Okay, cool. Busy tools 1. All right, cool. So we actually, obviously, we have no authentication against this API endpoint, which you should never use in the real world. So what we can do now, that's great. Now let's focus on the client. So what I'm going to do now, I'm going to hop over here. So I'm just going to pop over to a new shell. So we are here in this queue management side. We have a server, and obviously we have we got a Docker server running here with Redis. So I'm going to pop into client because this is going to be our Edge app. And then what I'm going to do, because I'm already logged into Screenly using the CLI, I can create an Edge app. So what I will do, I'm going to close this. So what I'm going to do now is I'm going to use Screenly dash help. All right. So the first thing I want to do is to create an Edge app. Create. I'm going to see what argument it takes. So I'm going to call this queue system. So now what you see here is I should create 2 files, a screenly.yaml file and an index.txt. Sorry. And this is just a sample app. And what's important here is that you could do this. So you could do Screenly Edge app run. And before you do that, you actually need to create a mock file data. And this data is what would be running on the actual day. So simulates a real device, right? So let's run it again. And as you can see here, greetings from unknown. And if we actually look in here, I want to import that, then mock data. If we look in here, you can see unknown. You can see all these variables, hardware type, my name, and all that. So it's actually referencing this as part of it. So this is the plumbing we're going to do for our Edge app that we're going to interact with our Docker container. So I'm going to kill this now, and I'm going to do this. So I'm going to go, let's just go down. And so now I'm going to tell this, in the folder, we are going to create a Screenly Edge that is going to interface with the container server that we just created. This will be the display customers. Let's see. Okay, cool. So let's keep things basic. No WebSocket. So in the real world, you probably want to use WebSocket to pause automatically. So let's use lazy polling. Let's use lazy polling against the CLI. Oh, sorry, API every 5 seconds. Not great practice, but you know, it's just a test. Replace index amount that we in this folder, and let's build. All right, let's build it out. And I'm going to also point it to the developer documentation for the Screenly CLI. So review the developer document for the screen and I'm gonna give it that. So again, this is just cursor doing its thing, right? So it doesn't know how to do Edge app. So let's start with that and see what it gets. Amazing. And cool, so it's already picked up this. It's gonna replace all this. Oh, cool, so it even picked all of that up. This is really cool. You know what? Let's just see what happens. Screenly Edge. All right, that's not quite right. Let's see what happens here. Why is it not pulling it? Inspect. Let's pull up the developer console. Yeah, it's course policy problems. So if you run this on a real device, you can use our course procs to bypass that. But let's make things simple. Let's disable course in the server for now. Obviously, you don't want to disable course in general if you can. But you know what? Let's keep things simple for now and just get this working. And I wonder if we have library loads on this, but let's see. So it's now, okay, import, make response, and it will disable the course policy. Okay. And you can see it's actually automatically reloading here as well already. So that's good. Oh, wow, look at that. So we have a system already. let's disable this. So now we have course. Now we have a till system working. All right, let's. Let's mark a till as unavailable. All right. Okay, so that's cool, but it's not probably what we want. We probably don't want that. So what we probably want is works. We want tills marked as on indefinitely. We don't know how we'll be busy. Okay, it interpreted it the wrong way. Okay, that's fine. All right, this is actually making good progress. All right. Let's see what it does. So we might need to restart our edge app here because I'm not sure if we got hot reloading on that. So you know what? Let's let it start there, and let's spin this up again. Great. All right. So we can see all the tills available. Let's mark till and 1 and 3 busy. Perfect. Boom. You know what? I don't like this style. Display them in. Let's not display busy tills in the edge app and just leave them. I don't love this. I don't love that this line here. So. And then again, I don't think I have a hot reload on this. I'm just gonna kill this and start again. Perfect. All right, let's see what happens. All right, till 2 to 4 available. Perfect. Great. So the API is working. No tests. Let's just bring till 1 back again. No. Oh. Okay. No. So let's mark. No. Okay, this is on to make mark till 1 as all right, so interesting. So it should be a post. Okay, yeah. Boom. To 1. Let's mark unavail. All right, that's perfect. Let's write a small Python, a small simulation script that randomly toggles. Actually, forget about that. We know it works. Good. All right, so this is basically what you will see in a real screen then. See, there's a bug there. So it looks like we have a bug here. It looks like we're not showing the screen properly in the lower hand corner. You can't do that because this is only available within the Edge app. So, so we have to do this. So this is the URL we'd actually hit. Let's just try that. I think it might just be this. No? No. All right, so let's see. Let's inspect. All right. So this is where it's getting. So, so we need to hit Screenly.js version 1. Let's actually do this instead. Let's do it properly. Because that's a better way to do it. All right, let's see what happens now. Let's kill this one and let's do it. Obviously, that was not great. So, seems like we killed, broke a lot of stuff. Okay. So we got. Looks like we broke the code somewhere. All right, so it seems like he's getting a bit confused here. All right, so we still have. Okay, now we brought back. We reversed some changes. All right. All right. So display one. So obviously we could have used Screenly metadata for this. So we can actually use, as you can see here, you can use the display name. Let's see what it actually is using. So it's using display, pull interval. It's hardcore to display. No, display one. Okay. Here's a snippet. Let's just see if we can get this working. All right, so let's see. Yeah. Code cafe display. That's what we have. Where did you get that from? I guess most of hardcore is somewhere in the mock code then. But in any case, we've accomplished our goal here. Obviously, we have no documentation for this, but what we do have is a functioning edge app showing a queue management system. So that took us like what, less than an hour to build from scratch. Not for production ready code, but nonetheless. In a real world environment, what you would have done is that you would set up proper authentication for the API that we're using. We would have done an integration with the POS system probably, or some kind of button probably even that you could use. And then you probably would have an API authentication against the API from the screen side as well. So we'd have used we would have used a secret for that, so we can authenticate with, let's say, a bearer token or something like that against the API from the display. What else would have we done? We would obviously have deployed this on a proper web server, not what we have here. So that's something that would have been done as well. So obviously running with proper HTTPS endpoint, so running that on a proper server. But other than that, I mean, the flow is there. There are definitely quirks in the system. It's definitely a proof of concept more so than anything ready to go. But nonetheless, like, it is working. And you kind of illustrate the point. Like, you can save a ton of time using the Screenly Edge app environment when you build these kind of applications. And last but not least, so we would have to do Screenly Edge app deploy, and that would have deployed it into Screenly as an Edge app, and then we could just schedule it to one or more of our screens. So you could use a Screenly Anywhere device, so basically any web browser. You could have used a Screenly Android app. You could have used a regular Screenly hardware device, like a Raspberry Pi or our x86 player, to deploy this in the real world. But the bottom line is that Screenly Edge app takes away a lot of the busy work and heavy lifting that you need to do. And we could literally vibe code our way to a call forwarding display in less than an hour, which I think is pretty cool. So that's all I had for today. Thank you.